Welcome everybody to this 10th Git convention on advances and applications of Git. So as you see, this time, due to the pandemic situation, we have an online version of this convention that we have been making since several years, each 2 years. So thanks so much to all of you for attending this live event. And thank you to all the contributors that has participated to this version of the convention and with all these videos that we have made public today. So I will go into the details of the news of this new version that we have released just today, the 15th version of Git. So here we have the presentation I will make from the news of the 15th version. So the structure, the outline of the talk will be, we will mainly focus in the main news of the pre-processing part, the customization, post-processing, the typical parts we split Git when we are explaining it to users. Then I will go to the main general news. I will point out the future lines we have, and this will, after this presentation, we will make a round table. Of course, telematic also, where we can answer your questions, and some of you and some of the contributors will maybe attend telematically also to answer or to comment things about this 15th version of Git. So let's go to the pre-processing part. We have implemented new formats for importing and exporting geometry and mesh. So this is one of the examples, the Collada format, which is a mesh format. We have implemented the import of this format, and with two versions, let's say, with two options. The first option is importing the mesh, as this model we see here. But we have also implemented the option to import automatically some textures attached to this mesh, which Collada format supports. So Git can import automatically these textures and see the image as you can see here. So here we can see an example of animation. This animation is an evacuation simulation of people in a building, and the people are represented with these textures. And the simulation is done with Cflow code. Sorry. Then we have also the new mesh format of Abacus. We can import directly in Git 15. Here you see an example of the volume mesh. Also the G-code format, which is a widely used format, used for mostly for machinery, for additive manufacturing processes, also for cutting engineering, for 3D printing. It's very used in this, and this format is typically defining the paths that the machine should go through for these machinery processes, and also defining how the machine will follow these paths in time. Here in this example, we can see the machinery of a boomerang. Exodus 2 format, which is an HDF5 format. The old one was the NetCDF based, and this one is in HDF5, which is the binary format more powerful, and it's typically used also for qubit Sandia measure, and it's also handled by Paraview. Then other things in pre-processing regarding the visualization. Now in Git we had some problems visualizing the labels of the entities sometimes, mostly when they were in the same place in the space. So you have two surfaces which have the same center, or the surface and the volume has the label in the same position. So the way that we had to detect this was just looking like here, look here, you see something strange and you detect that maybe you have two entities there. Now we have the option to highlight in red, with clicking the option in the contextual menu, highlight in red these cases where the labels are overlapped. So we can detect it graphically in a more efficient way and more clear way. Also, one thing regarding visualization in the pre-processing part, the contact volumes, they were just represented with the light blue color of the volumes of Git, but only the two surfaces of the contact volume. Now we are also representing with this dashed line with arrows the connections between these two, the virtual collections, let's say, because in geometry they are not that connections, but these connections representing the master and the top, the master and the slave surfaces and their orientation regarding the volume. So now it's easiest to detect graphically the contact volumes and their orientation. We have put a lot of effort in the hard refactoring process. Let's say we have changed internally the whole meshing process, and it has been enhanced a lot. The key point of here is just all the workflow that Git internally follows to mesh all the entities has been changed and has been made more independently, the meshing of each part of the model. So now it's more, the mesh generation has more parallelism in the process. In some cases now, there's no need to regenerate the mesh if the data affecting the model, it's not affecting directly the mesh generation. So if you change some property of the model which is not affecting the mesh generation, when you click on mesh generate mesh, the mesh is not generated again. So Git detects that should be the same, and you can save this time. And also we have detected several bottlenecks. Just improving this and changing this workflow for the meshing process, we have detected a lot of bottlenecks, and we have made some changes so the algorithms and the data structures are more efficient, and we have improved a lot the performance there, and of course the bugs that has been fixed during this whole process. A big change that we have now, so it's that Git now is prepared to maintain the connection between geometry and mesh. So in previous version, the mesh data was all put together in the project, and once the mesh is generated, we didn't have the connection between the mesh and the geometrical entities it comes from. Now Git is prepared for this, so it's not yet ready. The use of these functionalities is not yet ready for version 15, but it will be for very fast developer versions that we will release in next months, because Git is now internally working with this new way of dealing with the mesh and geometrical entities. So this will allow, first of all, a faster meshing process. So only the geometrical entities which have changed or with some mesh property of them has changed will generate a mesh again. The ones that has no change won't be generated again. So the meshing process will be faster. And also the automatic update of properties of the mesh when changing something of the geometrical that data, let's say, as an example. So if you generate a mesh of the whole model, you move one geometrical entity from one layer to another, the corresponding mesh will also be updated and will be in the new layer where the geometrical entity will be moved. So there will be no need to generate the mesh again in order to inherit these properties from the geometry to the mesh. So let's go to the main news in the customization part. I will explain a few of them. So we have a new package, a package Git graph included inside Git. So it's very easy to use. You can create your own graphs. You can, following this syntax, create these the graphs from a specific sets of data. We have also implemented the typical browser, the message box get file name, let's say. It was only available for selecting files, or in the case of Git, selecting the folders which ended in .git, which are the program types or the models. Now this window, this widget, let's say, can deal also with folders directly. So in some cases, the program types needed this to let the user select some folder, not some file. So now we can support this. And of course, a lot of commands and events that we are implementing each day or each month. So the complete list of them is in the Git customization manual that can be found here, as you can see in help, customization help. Then the main news in post-processing part, some of them. So now we can combine results and movement in the animation. So here you have the window controlling this and some example here. So you can see here the animation that it's done with the results, and the camera is moving and also the results are changing. So you can combine these things in this new version. And then some main general news. So the main general news we have here is that we have a new kind of license, which is the Git user license. If you open Git 15, you will see here this icon next to the logo that indicates it is logged in or not, if it has password or not. Here we have this icon, and if you click them, you enter to the options of the new Git user license. So this license is associated to the user. So it's a permanent license as the other ones. So previously we had local license, USB and floating licenses. Now you have a new one, which is named user. So you need to register to use this license. You need periodic internet connection, and you can use it everywhere. So it's not limited to a specific device or to be connected in a network with a floating server. So you can use it anywhere, just signing in Git. When you click on the icon, you see here, you put your email address, which is the username we use, your password, and then Git connect to our servers and detect that you have the license, and you can use that Git everywhere. So you can, everywhere you go, log in, open Git, sign in, and you can use Git in a professional mode. A new thing also regarding this kind of licensing, pricings, we have a new subscription system. So now user can apply to a subscription to Git. It can be monthly or yearly. You have options for automatic renewal or cancel anytime, of course. And it can be assignable to specific users. So we have thought about some typical case we had as an institution that has several researchers or a university with several students using it. So they should have a pool of some subscriptions, 10, 20, whatever. And then they can assign or unassign each one of the subscriptions to the users of Git. And if one researcher is coming new, you can assign the subscription to the new user if you want. All the details of these kind of subscriptions and all these things can be found here in our website in the subscription part. And at the user level, so all the subscriptions and all these new user-based licenses are managed in a new website we have, which is the license manager. So here you can see, you can change your personal data, you can see the status of your products, of your licenses, and all the typical stuff for managing these licenses. You can assign to another person one subscription you may have. Now we have also a specific window for registering Git. So in the help menu, register Git, previously we had local, USB and floating. Now we have also this new one, and each one of the options opens a specific window to deal with these licenses and to work with these passwords. We have new codecs for video creation, so the MP4, which is widely supported, new codecs for AVI, and also WebM with transparencies for internet browsers. So you can control the quality of the export of the video. Here are some examples. Of course, each kind of video have different properties and may create different size files. Here we see some examples. This is an example of AVI, the previous we had, and here we see the MP4, which as you see in the previous slide, it's smaller, the file, the output file. And here are some example of the WebM transparent with transparencies, which can be put in browser. Here we see some example of how it's put in the code of this website. And the important thing is that we have there the transparencies, and you see the things in the back part. So storing preferences and problem types. So now each version of Git stores independently its preferences. So if you work with different versions of Git, they know they don't fight with each other. So you open one version 15, or then you open one version 14. So they work with different sets of preferences. And now we also can load automatically problem types from stored in the preferences folder. So there was a problem before in the previous versions that some users may not have rights to write in the typical problem types folder, which is in problem data, Git, whatever. So now we can read also problem types from the preferences folder, which is more public, and we have no problem there for any user to work with. So the Git 15 graphical user interface is fully translated into Russian, apart from Spanish and English, of course. And now we have included in the Internet Retrieve also the translation of the different languages of the messages of the GUI. And now going to the future lines, some of them. So the part I told you about meshing will be totally linked to each geometrical entity. So this is pending to pass the quality controls before the public release. So with this big change, Git will only remesh what needed. Also, cloud services linked to user. We are working and have cloud services for model storage in cloud. Also, they store the Git preferences and properties of each session of Git. So everywhere you work with Git, you can load the preferences you used the last time you worked with it. And also this new subscription mode, we are studying how to offer the problem type developers this kind of licensing in order for them to work with it. And also the volume rendering, which is one thing that we had in mind in the past. Now we are also pushing to have volume rendering inside the post-processing part of Git. Okay, so now this is our last slide for the presentation for the news of Git 15. Now we're going to the round table. So I give pass to all my colleagues from the Git developer team, and we will begin this session for comments with all of you. Thanks so much. Okay, so hello, welcome all of you to this roundtable, to this strange Git convention, let's say. First of all, thanks to all of you for attending here, and also all the people connecting the YouTube channel. And of course, to all the contributors that you have made all these very nice videos. We have made it public today, explaining all the new things you have implemented these last years for these new problem types of Git, how you use Git, how you are connecting with Git functionality. So very thank you to, to all of you. So let's go through some, let's say, logistical things. So we hope that all this online live session will be okay. For all the speakers that are in this teleconference, just remind you what Anna has said. So if you have the YouTube channel opened, be sure that it's muted, not to have problems with the audio. And when you want to talk, to contribute with something, just raise your hand, and Anna or Javier will give you access. And be aware that all the things that you will explain, we are in the live session of YouTube. So it's all the things explained here are public, and there are several users which are not here in this telco, but are attending just as as public, and can hear and can see all the things that we are saying. So okay, just to begin, just make a round of presentation so we can introduce ourselves. So we will first of all introduce the members of the Git development team, and then Javier will give you pass to each one of you, just to say who you are and which is your field and where you come from which institution. And be aware that every time that you will talk, the image of Zoom will be seen in the YouTube channel. Okay? So let's begin by myself, Javier, and then we go pass to the rest of the members of the Git team, and Javier will introduce each of you. He will give you pass to present yourselves. So I'm Abel Coy. I'm the head of the Git development team. I'm here from CIMNE, of course, and my research field and I'm focused on mesh generation and geometry, so more in the pre-processing part of Git. So I give the word to Javier, who will manage all the other introductions.
Okay, so hi, I'm Javier. I work in the GAD team since like 5 years ago, and I'm now working on the new license system, which is user-based on your current email. So it's about to make your life easier when using GAD. Adrià?
Hi, I am Adrià Melendo. I am a mathematician, and I am in charge of team organization and also collaborate in geometry and on interface.
Your turn.
Okay, hi. My name is Ana Monros, and I'm also working for the Git team. I'm more in the post-processing part, and also I work in the graphical user interface as well as the user experience. And I am also the responsible of the communication part of the Git.
Enrique Escolano.
Well, hello. My name is Enrique Escolano. I am a civil engineer, and I have been working on Git for more than 20 years, maybe about 24 or years. I am mainly working in the pre-process part, in geometry, CAD, import, export of different formats, and also in customization. So TCL, TK, interface, and customization in general.
Okay, now it's turn of Miguel Pasenao.
Hi, my name is Miguel Pasenao. I'm in charge of the post-process part of Git. I'm also in the visualization. I'm responsible of porting Git to Linux and macOS. So I'm part of the Git team since the beginning. So that's all. If you have any question regarding new things and visualization and post-process, I'm your man.
Okay, and now our new incorporation, it's Laura Santos.
Hello, I am Laura Santos, a computer scientist, the new member of the Git team, and I am working on web and cloud topics.
Okay. Okay, now it's time for the speakers who are not in CIMNE right now. So let's start, for example, with Alfonso Rodriguez.
Hello, good afternoon. My name is Alfonso Rodriguez Dono, and I'm a geotechnical engineer working at UPC, and I'm part of the CodeBright team.
Okay, let's connect with Christian Souto.
Hello, my name is Christian. I'm a civil engineer, and since more or less a year, I work with Iber team in the problem type, improving new functionalities of Iber.
Okay, let's connect with Miguel Ángel Celigueta.
Hi everyone, this is Miguel Ángel Celigueta. I am a researcher at CIMNE, and I've been working in many research projects through my career related to fluids, particles, and now I'm heading the team which develops the particle software. I've been also working with the creation of many different graphical user interfaces, including the commercial software that I presented this morning in the talk, the SpreadDEM.
Thanks. Let's go with Gaia Di Carluccio.
Hello to everyone. My name is Gaia Di Carluccio, and I'm a PhD student, yes, at Polytechnic University of Catalonia. And I'm in the developer team of the NPM Anura 3D software. And my research is focused on the implementation of constitutive models in the NPM and on the simulation of liquefaction of soils.
So let's connect with Dr. Jan Cervenka.
Yes, hello everybody. I'm happy to be part of this Git convention, even though it's online. It would have been much better to come to Barcelona and to see all of you. Anyway, I'm from a company located in Prague, Czech Republic, and we use Git program as a preprocessor for our commercial program Athena, which is devoted or which concentrates on nonlinear analysis of reinforced concrete structures. So thank you for your attention.
Thanks. Let's connect with Francesc Duron.
Hello, my name is Francesc. I'm a naval engineer, and I have just started my doctoral thesis here in CIMNE. And well, recently I have been working with CIMNE team in the new problem type of PLCD, the software that we use here. Well, we are a very big team. For example, we have also here Lucia with us. It's still an open project, but we begin to have a software to work with.
Okay, so let's start with Lucia.
Hello, everybody. My name is Lucia Barbu. I'm a researcher at CIMNE also. And since some 10 years ago, I have been working with PLCD, which is a finite element code we developed at CIMNE for nonlinear resolution of composite materials, nonlinear behavior of composite materials, and also some other specific nonlinear problems that we solve. Today I participate here representing the PLCD team, which has a very nice interface inside Git. And I hope that you were able to listen to Francesc's talk where he presented a little bit about our problem type. Thank you very much.
Okay, thanks. Let's connect with David Vicente.
Hello everyone, my name is David Vicente. I'm also a researcher in CIMNE. I work in Madrid, in the Department of Machine Learning in civil engineering. My research lines are related to water distribution systems and active leakage control. I also collaborate in projects related to dam engineering. I'm here in this convention. I'm presenting a tool that we have developed in CIMNE Madrid to simulate leakages and intrusions in single pipes.
So let's connect with Eduardo Souda.
Hello, everyone. My name is Eduardo Souda. I am a researcher also at CIMNE. I am a coordinator of biomedical engineering group at CIMNE, and our research line are all try to apply numerical methods to solve biomedical problems, and also try to use finite methods in order to improve the design of medical devices. Thank you.
Okay, it's time to present Ricardo Rossi.
Hello everyone, my name is Ricardo Rossi. I am an associate professor at the UPC, and well, I also collaborate with CIMNE, where I am the head of the Kratos Multiphysics group. I consider myself a user of GID, very interested in the development.
Okay, now it's Fernando Salazar.
Hello, goodbye. I'm Fernando Salazar. I am the head of the CIMNE Madrid group, and we are also users of Git, and our main research lines have to do with dams, dam engineering, and hydraulic structures. So we develop our problem types to use codes related to the safety assessment, considering both the fluids and also the structural integrity of the dam.
Okay, Fernando, I think we are having a little trouble with your microphone. We hear you, but a little low, but it's enough, I think, for now.
Okay. Sorry.
Okay, it's nice. Now we have Luis Manuel Diaz, I think. Having problems. Okay. We're having problems, I think. So let's go with Ernest Blade.
Well, 1 second. Oh. Hello, I am Ernest Blade, and I have been working with Iber since many years ago, developing Iber. No? And we develop Iber based on Git, and Git has been an extraordinary tool for the interface for pre-processing and post-processing, and we are still continuing developing Iber.
Okay, thanks, Ernest. So we are all presented. Let's connect with Abel.
Okay, so now we already have all people presented. We all know who we are, let's say. So now the plan is to we will manage the chat of the YouTube. So we will read all the contributions and all the questions that the public may write down in this chat. But first of all, let's open to all of you. If you want to make some comment, if you want to ask something to some of the members of the Git development team, some general question, some specific question regarding Git 15. So the first part, we are devoting this just to give you the word in order to comment something, or if you want to ask something to us. So the way we think to make it is each one of you that wants to comment something, just raise your hand, and Javier will give you the word one after the other.
Okay, we're gonna retry with Luis Miguel Diaz. So maybe.
Hola. Okay. I'm Luis Manuel Diaz Angulo. I have problems with the audio, and I'm also having problems with the video. I'm from the University of Granada. I am the developer of one developer of SEMBA, the electromagnetic compatibility simulator, which is a problem type for GID.
Okay, so if you have any questions or any comment to make, it's your time. Okay, so while you think the questions or the comments, we have a question via YouTube. One user is asking us, are you planning to use the GID stereoscopic features to facilitate viewing 3D results on virtual reality devices? So maybe Miguel can answer these questions. Where are you? Here.
Yes, thanks for the question. Well, currently Git can create stereoscopic videos that can be viewed with, for instance, with NVIDIA 3D Vision players and other similar players that can also drive virtual reality devices. Git can also create stereoscopic views using professional cards like NVIDIA Quadro or AMD 5GL. In the roadmap, we are planning also to implement this stereoscopic view for normal graphic cards like NVIDIA GTX 1050 or the like. The thing is that the approach to implement this possibility is quite different than the normal professional graphics part, because they use standard features implemented in OpenGL, which are not implemented in the consumer cards. These consumer cards are the typically used for augmented reality and virtual reality devices. So it's on the roadmap.
Okay, thanks, Miguel, for the answer. I see no raised hands, one from Miguel and another from Miguel Angel. Let's start with Miguel Angel first.
Yeah, I didn't know that, as Abel said in the presentation, the new Git will allow to make animations and at the same time moving the camera. Will that allow just rotations or also translation, zoom in, zoom out? Is it flexible to make any kind of animation of movement of camera?
Let's allow Miguel to answer.
Thanks for the question, Miguel Angel. The thing is, we are there was a window that you can develop your own scripts to do this complex movement. But what we have done now is, in the same window that you animate the results, there are at the moment 3 simple animations: just rotation, zoom in, zoom out animations. And this will be a start for a new and more easy to use approach to develop your own animations, because now you have to deal with 2 separate windows, and we want to integrate them into one single window to have, for instance, one track for the movement of the model and another track of the result visualization of the model and another one for the effects that you want to give to your model. For instance, transparency, lightning, shadows, and so on. This is the concept that we will follow behind. We started with this simple animation, so that in the same window that you animate the result, you can choose at the moment one of the 3 simple animations.
No, I was just saying thank you, Miguel.
You're welcome.
Let's connect with Ricardo and then Lucia Barbu.
This exporting happens also through the Collada, or that's a different, I misunderstood?
So Enrique will answer this question. Where are you in the panel? Where are so many people? Okay.
At this time, there is only the plugin option to import the Collada format. This plugin is only for import, not to export, but probably in the future will be enhanced to also store information. And when you import not all the Collada is a very big format and very importing some parts, but the most important I think are implemented. And import basically the mesh information, and also some colors and map textures on the mesh. But probably in the future will appear export option also.
Thanks.
La réplica. Okay, so it's time for Lucia Barbu.
Yes, I have a question about what you explained, Abel, that the mesh will have information from the geometry. Let's say that they will be linked somehow. Sometimes when we have to work with geometries created in other softwares and we import the mesh inside Git, we need to do some operations on the geometry. Maybe we need to add something else or work in this way. Is this a first step to be able to generate the geometry from an important mesh inside Git? Or are we close to this? Or is it still completely unfeasible?
Okay, so the magic question that every Git convention appears. So this has nothing to do with the thing that I have explained. They are totally different things. One thing is, sorry, one thing is the tools we have to reconstruct geometry from mesh data, which we have some of them inside Git, as you know, but maybe they are not so robust, or maybe they are not so general, let's say. So importing a arbitrary mesh or creating just a patch of surfaces there is not obvious. So we have tools there, but in this 15th version, we have no news there. So we have the tools we had before. The new I presented was more related in how the data is stored. So in previous versions of Git, the meshing process works like this. So Git goes entity by entity. So get one line, mesh the line, get the other line, mesh the line, get one surface with all the lines meshed and mesh the surface. So during the meshing process, Git, of course, has the information of the geometrical entity corresponding to the mesh that is being generated. But when the meshing process has finished, Git put all that meshes together. So what happened now, what happened in previous versions, that once the mesh is generated, you cannot identify, or you cannot know each piece of the mesh, which is the geometrical entity it comes from. So this is the thing that is changing now. And this opens several new functionalities and more, let's say, a more efficient way to treat the data inside Git. Something like you generate the mesh of the whole model, you change one property of some of the entities or some of the surfaces or the volumes. So if this property is affecting how the mesh is generated, Git, when you click on mesh, generate mesh, will generate the mesh of that entity, but not the mesh of the other ones, which still remains the same. Okay, so you change the size of one entity, so the mesh is generated again only on that entity, and the entity is affected by this size. So maybe some more of them. So Git is automatically dealing with all this information. So in practice, this will lead to generate much less meshes than before, because if the typical process that you generate one mesh, you change some size here, then you move some layers, or you apply some condition there or whatever. So if you apply one condition to one surface, automatically this condition will be applied to the mesh of that surface, and it's not need to generate the mesh again. So it's more related with how Git stores the data. So sorry for that, Lucia. This will be a big change, but not the one that you are looking for, maybe.
Okay, thank you, Abel.
Okay, we have a question in the YouTube channel. They are asking us to explain a little bit more the new license of GID. So again, Abel will explain.
Okay. So yes, this is, as you can see, this is one of the main news of this version. So we have made several efforts there in order to reach this new kind of license, which we think it's the more, I don't know how to say it, but it's the more user-friendly license. So until now, as you know, we had 3 types of licenses: the local, the USB, and the floating license. One was attached to a computer, the other one attached to a USB memory stick, and the other one attached to a server, to a license server. So all the computers connected to that server can see if they had license or not. So the new license we have now, so we have, let's say 2 news in this field. One is that we have the new user license, which is also a permanent license. So as the other ones, you pay for the license and you have Git for life. But how it works, it's linked to the user, not to the devices. So when you go to any device, you open, if Git is not installed in that device, you download Git there. But you open that Git, you click on the icon of the upper right part of the window, and you put your username there, which is the email. You put the email there, you put the password, and Git automatically connects to our servers and check if you have this kind of license. If you have this license, Git enter into professional mode. So the same as the local USB or floating license we had before. But this license is linked to the user. So if I put my email in one Git of any computer, and I have this kind of license, I can use Git professionally in everywhere. This is the permanent license, the new permanent license we have. And beside this, we also have, as a new in this version, the possibility to make subscriptions. So user can subscribe Git and pay monthly or yearly. We have these 2 versions. So you, instead of paying once and you get Git for life, you can make a subscription, a typical subscription like Netflix or Spotify or whatever, and you pay periodically the time you want. Of course, you can cancel your subscription anytime you want, and it works also attached to the user. So if you have some of these subscriptions, when you open Git, you can sign in that Git with that icon I showed you. You put your username, you put your password, Git connects to our license server, and then you can work in professional mode everywhere you are. So there's no need to link the license to any device, let's say. So I guess this is more or less well explained. Oh, another thing, the permanent license, as you see, works like the other. So you can get the licenses in the online shop, and then you have to go to our website to validate it. So the process is similar to the previous ones. And the subscriptions, by the moment, they are only available for Git, not for problem types, let's say. So briefly, next month, we will prepare all these subscription system to offer them also to problem types. So if some problem type, which is commercial, wants to give this subscription system to the users, so we will prepare all the system to work also with problem types. Now it's only ready for a naked Git, let's say.
Thanks, Adel.
Just a remind that right now we are offering 3 months for trying the subscriptions to all the users that owns a Git license. So if you own already a license of Git, you can just register on the license manager and you will have 3 months of free for trying the new subscription. So it's a great offer.
Okay, thanks, Adriel, for the commercial advert. It's turn for a question from Gaia, which is here. Okay.
Yes, thank you. I have just a comment related with the previous topic of the regeneration of the mesh, because in Anura 3D, we don't use layering when we create a model. So I wanted to ask if this new tool, for which you don't need to regenerate the mesh if you change something in the layer, can work also in our case. So if you change something to a surface or a volumes without layers.
Yes, okay. The layer was just an example. So the thing is, imagine you have 2 surfaces, and I don't know, I change the size of this surface, or this surface is in layer 2, I pass this surface to layer 3. But it's just an example. But the thing is that if you change something of your model that is not affecting how the mesh is generated, as now Git will know that which is the mesh coming from that entity, the mesh won't be generated again. So the typical examples are like this: like you change one size to one entity, the other one is there's no need to be regenerated. You assign conditions to a volume, and the volume already has the mesh, so that conditions will be transferred to the mesh without the need of regenerating the mesh again.
Okay, so we have a question for the Kratos team. So I don't know if Ricardo or Miguel Angel is. The question is asking about the Mac version of Kratos. I don't know who is. Maybe Ricardo. Can you answer this one?
Well, we have some users that are compiling their own version for Mac. So on the Kratos side, there is no problem. I would ask the same question to the Git. So, I mean, but we would be willing if there was a support.
Okay, and a similar question for the Iber people about a version in Linux. So maybe Ernest, it's for you, this one. No sé si Ernest. Okay, maybe Christian can answer this one.
I think yes, is there's a Linux version for Iber. A Mac version is not available and is no, is not for the moment. We will be not developed, but there's a Linux version. I think.
Okay. So Abel has a comment.
Okay, I have just a curiosity, let's say, or a comment to our colleagues from Madrid. So I don't know if Fernando Salazar or maybe David Vicente. The thing was both the two applications you have presented, the one from leaks and the one from the dams, just to know which was the motivation of this new application. So it was just to cover some need in the industry of civil engineering, or it was more focused on research for some research programs or projects or all this? So I don't know if Vicente or Fernando, I don't know. Raise your hand, the one that wants to answer.
Okay, you have both the voice.
Okay. First, please let me know if now you can hear me better than before.
Yes.
Okay. So, well, both applications. Well, I suggest I can answer for the Kala application, and maybe David can later answer for the application he developed. We work mainly in research projects, but quite applied ones. So at the end of the projects, we always are, or quite often, are asked to end up with some application or something that can be easily used by people who are not familiar with pre and post processing, and even with numerical modeling. So, for example, the Kala application has to do with.
Oh, we have lost Fernando.
Maybe you can continue with
Spillways, dams, and can you hear me?
Yes, now. Oh, yeah. Now we are hearing you.
Well, I was saying that although people can, of course, learn how to use Git and generate the geometry and generate the mesh, etc., our partners in the project quite often ask for something even easier, so that they can just introduce a few parameters and automatically generate geometry and mesh. For example, they don't need to know or to learn which mesh size they need to use. Let's say that we do that work for them, and we test different options, and then we implement those options into some wizard that is quite easy for them to use. So that's our main, goal or the motivation for this interface to be developed. And now, David, if you want, you can complete this.
Yes, no, only to add something that in the specific case of the tool I have presented related to leaks and intrusions, that of the Kala that was presented by our colleague Javier was more related to one research project that is in progress. In this other case, the leaks and intrusion was made with the idea of make a prototype to improve one research line that we are continuing working in, that is the active leakage control in water utilities, and the main advantage of this kind of problem types, as Fernando has said, is that they are very useful to show other people, other partners, or to search for other partners for future work. So we like to use all the capabilities of GID in this context, and we are very happy to use it and to create this kind of problem types.
Okay, pues thanks Fernando and Vicente David for the answer. I think Eduardo Souda has a question or a comment.
Thank you, Javier. Yes, my question is related for the meshing part. So, are you thinking to generate a volume mesh directly from the STL mesh without passing for the geometry?
Yes, Eduardo. So we have already some tools there and some measures working with getting an STL, a typical STL file as an input. Well, we should improve these measures and these options, but we have some of them already there. Yeah.
Thank you, Abel.
Okay. Okay, so Fernando, again for you.
Yes. Well, I want to make a question or a suggestion. I'm sorry, I think this option is not available in post-processing now in Git. If it is, I'm sorry. I've seen in some conferences some other softwares that allow the possibility of recording a video of the process of some transient analysis, where you can see both the results, the evolution, for example, of the contour field, together with a point graph. And I find this outcome quite interesting, because you can see not only the contour field, but also the evolution of some output variable and how it evolves in parallel with the picture. I don't know if you know what I mean. And I found this quite interesting too, because you know, sometimes it's not that easy, because when you record a video with the contour field evolution of some variable, the color scale, well, by default it changes with it adapts to the maximum and minimum value at its time step. You can of course check what is the maximum and the minimum for that period and fix it. But you know, watching the contour field together with the evolution and actual value of some output variable in one or several points is quite interesting. I found it useful. And so I don't know if this option is available, and you are thinking of.
No, currently this option is not available. But if I get your idea, you mean that, for instance, having half the screen with the contour field animation and the other half with the graph, and then, for instance, a bullet that is moving through the graph while the animation is moving along the time step. Is that right? Fernando? One moment. Well,
yeah, well, that's an option. You mean you can see the graph and one bar that is moving? That's what you said. That's an option. Another option, maybe more complicated, is to actually drawing the
drawing the graph. Yes.
But the first option could be also useful, and maybe it's easier for you to develop.
No,
anyway.
Well, both options are more or less the same. The complication of both options is the same. The complexity of both options is the same. It's an interesting option to be added. Another, just no detail, you know that in the preference windows of the contour field, you can also set the minimum and maximum value for the whole analysis. So you don't have to calculate the minimum and maximum values and then set it manually. There's an option to select minimum, maximum of the current step or all steps.
Okay. I didn't know. Yeah, thank you. So thank you.
But we will add this feature to the wish list for the next version. Thanks.
So we have a question for, I think it's for Quique Escolano. Which kind of new formats for import have we got in this new GID, and which formats will we have in the developers, in the next developers, if you know?
Well, the list of formats is a very big list. The better is to see the menu files in PostScore in pre and post processors, because some tools are only available maybe pre or maybe only in post. And it's important to see, for example, formats that have results are only available in post-process part to also explore results like BTK, for example. And I think that seeing the question by writing, I think that maybe it's interesting in some formats, or like formats of Revit or FBX, and are very typical of building sector. And I think the most important problem to implement these formats is that they are not public formats. They are private formats of Fabric software, and it is not possible to see any documentation. It's only possible to maybe to base on some library that are not public. And this is a main problem to implement it. We are usually implementing only public or documented formats. Then for this kind of industry like BIM, maybe we will implement in the future some like EFX, EXC format that is a more or less standard format. We are developing also depending on the new necessities. Along these next years, we will implement most formats depending on how people are asking the importance of these implementations. Of course, we will implement more and more. They are typically implemented as plugins. They are like external to Git, and you can add a plugin only to add these new features.
Okay, so thanks, Kike, for your answer. Let's connect with Abel.
Yes, I have some comment for you, Jan. So first of all, hello again. And just during these last 2 years, since the previous version, since 14th version, we have implemented some improvements, and we have, with your help, we have detected some bugs in the contact volumes and semi-structured volumes and all this stuff that you work with every day. So just to have a feedback if these improvements and these bugs fixing, whatever. So if now you have found, because I know you work with developer versions, so for you the 15th version, it's a little bit more than the last developer version of 14th. So you have checked several of these things. Just to know if things in that stuff of contact volumes, semi-structured volumes, whatever, are working better now than before.
Yeah, Abel, thank you for your question. I think I must say I have not yet. We don't have yet so many experiences with the latest development version, so I am really waiting for the version 15. I must say I'm myself also not fully sure what is how big is the difference between the version 15 and what was before called developer version 14 something. But what I have an experience with are the previous official versions. Yeah, so you always release subsequent versions of the version 14, and definitely there was an improvement. There is an improvement. Yes, it's getting better and more stable. But as far as my experience was from these 14 versions, those official versions, not so many experiences with the developer version, because for these complicated problems, we are usually using the release versions, not the developer version. Okay, so there is an improvement, but still, sometimes it crashes. Yes.
Yeah, I know. So for us, the models you send and the problems you find with this kind of complex models are very useful for us, as you know, because you find several strange configurations of topologies of geometry, which are very useful for us to detect these things.
Yeah, so unfortunately, usually what happens is that we are trying to have models which more or less mainly use brick elements. Mm-hmm. That means we assemble the model such that it consists of many structured meshes combined with semi-structured meshes. And I can understand there are a lot of links there between the various regions. And this, I think, is causing sometimes problems.
Okay, so we wait for your feedback for this 15th version in these fields, which we are continuously trying to improve this.
I'm looking forward to try it more on some of the more complex problems.
Thanks so much, Jan. So, and then we have few time because the session is ending at 5:15. If there's some more comments, I would like to make some comment for Alfonso, sorry, for the code right. Just to know a little bit, which are your requirements concerning Git for the next steps of your program? So let's say, if you think about the next 2 years, for example, which will be the big things you will you will put in a wish list. So we ask Git to do this and this and this, and we will be able to do this other thing that we are not making it now.
Okay, so thank you for your question. It is really a good question. Well, actually, I was interested in making you a question related with the mesh because I was interested in knowing a little bit how but a little bit more technically how the smooth contour field works. And about what will we need in the next 2 years. Well, we will work for sure in for example in gas migration in some geomaterials. So it will be interesting to detect paths of fracture. So I'm not sure if maybe the mesh can help us, but I don't know. We have to think about it. I mean, because there is going to be some fracture. So I'm thinking maybe we can allow some nodes to duplicate, so they can move one from each other, but well, we didn't think deep about it.
Okay, so these topics about fractures depends strongly on the numerical method you use. So as we are close physically, so when you attack these problems, so we can of course talk. And if you need some specific tool concerning in this case concerning the mesh generation maybe, or the topology of the geometry you work with, so we can talk about this in next days.
Okay, thank you.
And sorry, and the part you say regarding the smooth contour field. So could you specify which is the question, or maybe if you say it's more technical, you can write an email if you want. I don't know.
Okay. Yes. Well, because contour field is very clear. For example, we have some results that are written in nodes, and another results that are element results. So each element has an associated result, right? So, for example, when we have a result associated to an element of the mesh, then in contour field, we have that result in some color, okay? For example, pressure, we have, not pressure because pressure is in nodes, but for example, water saturation, we have some result, okay? But then when we press a smooth contour field, then this result is much smooth, because otherwise every element have a different color, okay? So what I wanted to know is which technique is it used to assign these colors? If for example, the results of the elements are calculated with some method in the nodes, and with that you make the new contour. Or but if you want, I can make these questions by email. Yes.
Okay, perfect. No problem. Great. Okay, there's some other comments. So maybe Luis Manuel Diaz, we cannot see you, and we cannot see if you are raising the hand or not.
No, I am not. I don't know. I have a problem with the video. I couldn't fix it.
Okay. So there's any other comment? Any one of you wants to ask something or make some comment?
Okay, we have a question in the YouTube channel written by Jan Cervenka. So I think I can unmute him and let him ask it.
Yeah, the question was, well, it was not a question, but it was a response to your question about new features. So one interesting feature for us would be to have an import or capability for import IFC file, which is like a BIM type of file. So IFC is basically ISO standard for BIM data for civil engineering structures.
Well, as I say, we are interested in develop more and more import and export options, and this IFC is an open format that is very similar to the STEP format, and we have the libraries to do the parsing of STEP, and this will be a more or less easy to read also the EFC. Then there is also necessary, of course, what is read to be transformed in Git entities. It's not work, but I think that will be one of the next possible formats to be implemented. And probably the most interesting part for us is before the import and then the export part. So for us, it's more important to read the geometry, to work with it, than the export part. Then probably we start implementing the import of the format, and maybe later the export.
Okay, thank you.
Okay, so I have a personal question for Miguel Angel about if it was easy for you or for your team to create your product, which is based on Kratos, but for a commercial purpose. So it has to just explain your experience, if it was easy or difficult.
Our experience was that well, the people in the team were not experts in TCL/TK. They have some experience, but they were not experts. And everything that we could not do could be solved in, let's say, affordable time, in a matter of hours. Everything that was blocking us could be solved in a matter of hours, especially if there was a fluid communication with the GAD team. So I would say that everything is possible if there is some support from the GAD team, because if you cannot solve it by yourselves, looking at the help or Googling TCL or TK, whatever, then the Git team can help them. So I think everything is possible if you have support of some kind.
Okay, so let's hope you have the support you need so we can continue growing together. Yeah. Okay, if there is no any else. Okay, Fernando, you have something?
I don't know if we have time. In case we have time, I would like to make a question and take this opportunity of having all the Git team here together listening. So yeah, I was wondering if you, we're starting working with a consideration of uncertainty, meaning that we would like to run a number of simulations modifying certain parameters following a certain distribution. And I wanted to know if this request or this need was shared with other people using Git, and if you had this in mind for the wish list. You know, in the past, in a previous project, David Vicente here, he developed something like an interface using Git also to generate automatically a set of models modifying certain parameters. But you know, I don't know if this is a more general purpose or effort to implement this into into Git.
Okay, let's let Kike answer this one.
Well, we don't have any specific plan to do this kind of similar analysis, but I think that probably it's necessary to do some kind of macro problem type to parameterize your kind of model. Probably this step is necessary in most cases.
I mean, it can be done. Actually, we did it. So, but I was wondering if any other group or people working with the idea had raised this question.
Yeah, because there are more people that have these similar requirements, but I don't know exactly what we can do in a general way. That to aid. Do you have some specific commentaries about what it can do to aid you, to aid a problem type to develop easily this kind of?
Yeah, I guess that I'm not sure if it can be done generally. I mean, or if it needs to be solved for its specific code or its specific solver that you use it. But maybe some of the kind of variables or parameters might be introduced into Git. I mean, for example, I think it could be easy to let the user choose whether some, for example, some feature of some material has a single value, is deterministic, or if it is random, following some distribution. And these distributions could be implemented into Git so that you don't need to code it. Just take this uniformly random and generate a number of models and modifying this parameter randomly between this and this other range, value, etc. Again, I'm not sure if it's worth the effort to implement it in general. It can be done with not that with a little effort as we did in the past, but I had this curiosity about if any other people had been working.
Maybe for simple parameters like the property of some material, maybe it's easy to do some kind of random simulation and represent this in some way. The more difficult part probably is if they are geometrical parameterization that are more depending on each case. But maybe we can add some tool to at least run a collection of cases with a stochastical distribution.
Okay, thank you.
Okay, I think Jan has a question or comment.
Yes, I would like to comment on this question for the probabilistic of this. We actually do this a lot, but we do it externally, yes, because it is quite problematic. It is not just a matter of adding a probabilistic function or distribution to a certain parameter. Because imagine you have more parameters, then you need to have some correlation between them and you need to apply various statistical methods. So of course it would be nice, but it is really getting into an area of probabilistic modeling where there are many issues. So I think if you need to do that, it is actually quite easy, especially if GID has this TCL program, the scripting language, to run this, let's say, externally. Either that's what we do. We generate an input file for software from Git, and then we run this input file through some parser, which then makes this parameterization. Other possibility would be that you can do this parameterization directly through TCL language in GID, which we are not doing, but it would be possible. So I don't know, but I think it's a very complex problem, this probabilistic modeling, which is a little bit out of the scope of Git, I think.
Okay. So let's connect with Abel again.
Okay, so there's any other comment, any other question? We have heard something of almost all of you. So if there's no more comments, of course, we I heard it twice, I think. Maybe. Okay, no, sorry. So if there's no more comments, just thank all of you again to be here in this very strange Git convention due to this pandemic. So hopefully the next one will be physically. We can meet physically, and you could join the beer that we will make for sure right now. So it's pending this matter. Okay, so in the next one, Git will put the beer, and after the Git convention, all of you are totally invited to come here physically in Barcelona. Hopefully this pandemic situation will be out of our lives. And thanks to all of you for attending and for all your videos. Thank you very much for all the videos. It's I know that you have made a lot of effort there. It's very valuable for us to have this multimedia information in our website and in the material for the Git convention. And last but not least, just give my thanks to the organizers of this event, mainly Anna Monros, which is here in in the first part of the table, and also Javi Garate, which have fight with all these technical things, how to connect, how to make the Zoom, how to prepare all these events. So thanks to you for this. And of course, thanks to all the Git development team for the 15th version that is there and has all the things it has because of all our implementations, all our things from the team, let's say. So if there's no more comments, I just say you goodbye. I hopefully see you, some of you we will see next days here in Simne in Barcelona, but the other ones try to see you soon if the pandemic situation allows us to do so. So thanks so much to all of you, and bye.